Hello guys, and welcome back to another episode of chemistry. And of course, today we are jumping into another aspect of organic chemistry titled benzene and its compound. Benzene and its compounds. Okay, and this benzene and its compound altogether they are called arenes. So if you do not see benzene and its compounds, then of course you should be seeing arenes also. All right. So all benzene and its derivatives, okay, all the toluene, all the benzoic acid, and so on and so forth, which we are going to see very soon. All right, they are all called arenes. All right. So do not forget that this tutorial, of course, is brought to you by the one and only O3 Schools JAMB CBT practice app. Okay. Remember, there's also a WAEC app. All right. So it is designed to make you succeed in your exam. All right. So if you want to succeed and not suck seeds, please jump to Play Store immediately and download the application and start practicing your way to success. The app has helped millions of people and your case will not be different. All right. So this is a question from the app. Before we talk about the app, let us see a question from the app pertaining to this topic. It's a 2022 question number 19. 2022 question number 19. It says, dash is a hydrocarbon with a number of double bonds that interact with each other. Okay, so dash is a hydrocarbon with a number of double bonds that interact with each other. A says arene, B say haloalkane, C say ethane, D says ethene. Okay, so we'll be back to this question and many more after the end of this class. All right, because in O3 schools, what we do first is that what we teach you and then we answer questions with you. Thereby, you understand and you build your confidence towards your exam. So that is why you need that application, because the app has all the past questions from JAMB. What's more is that it has lecture notes structured according to the JAMB syllabus. So you do not need to go and buy any textbook. Another thing is that there's a question search feature. So you can just go to the question search feature and search for benzene now after we're done with benzene. All the questions that JAMB has said from past years under benzene will come up to it for you to answer. What is also more special again is the UTME mock challenge. It's a challenge that will conduct for all students that are writing JAMB for this year. You compete with your mates, win amazing prizes, but that is not even the bane of it all. The most important thing is that you are getting used to JAMB past questions, getting used to JAMB likely exam questions. You are seeing your score released every Saturday in that mock exam, and then you are building your confidence towards the main exam. Remember, early preparation prevents poor performance. So if you want to succeed and perform well, all right, start preparing immediately. Let us go to the board. At the end of the class, we'll answer questions from the application. So please go to Play Store, download the application immediately, activate. Activation fee is just a little token. All right, so let's continue. Benzene and its compounds. Okay, now we say they are called arenes. It is important to know that benzene is the simplest organic aromatic hydrocarbon. Okay, it's the simplest organic aromatic hydrocarbon. Okay, it is of course one of the elementary petrochemical and natural constituents of crude oil. All right, it is of course one of the elementary petrochemical and natural constituents of crude oil. So it is the simplest benzene, the simplest organic aromatic hydrocarbon. In fact, all other aromatic hydrocarbons are derivatives of benzene. So it is from benzene we get others that will derive what others from. Okay, so please take note of that, right? Also, it's also important to know that it has a gasoline-like odor. Gasoline-like odor. All right, and it is a colorless liquid. This is odor, please. Odor. And it is what? A colorless liquid. Please take note of that. We say benzene is the simplest organic aromatic hydrocarbon, and it has a gasoline-like odor. The formula for benzene is Is C6H6. All right. Benzene has 6 carbons. It has 6 hydrogen atoms also. All right. It has 6 carbons. It also has 6 hydrogen atoms. Likewise, it is important to know that it is highly toxic. It is highly toxic and carcinogenic. It is highly toxic and carcinogenic. The condition, you know what carcinogenic means, right? It means that benzene is a carcinogen. Carcinogen, biology student, okay? It means that benzene is a carcinogen. A carcinogen means that what? It can cause cancer. It causes cancer. All right? It causes cancer. That's what carcinogen means. All right? So it is highly toxic. Benzene is highly toxic and carcinogenic. It causes cancer. The condition is actually called leukemia. Leukemia. All right? And of course, it is this leukemia, the type of leukemia it causes benzene. When you expose yourself to benzene, it causes what? A special type of leukemia called acute myeloid leukemia. All right, so benzene causes what? Leukemia. It's a cancer-causing agent. Okay, so when you overexpose yourself to benzene, all right, you are going to have what? Leukemia. All right, so please, benzene is a carcinogen. It causes cancer. You have to take note of what? Of that. All right, so now benzene has a general formula, as a formula of what? C6H6. Like we say, benzene has a formula, not general formula, has a formula of what? C6H6. You must take note of that. And we said that it has what? A gasoline-like what odor. All right, it's a colorless what? Clear liquid. All right, it's a colorless what? Liquid, and it has what? A sweet smell also. That's a sweet smell. All right, so you must take note of that. Then of course, benzene. The word benzene itself was gotten from the word called benzoin. Okay, it was gotten from a word called gum benzoin, or sometimes this gum benzoin is called Benjamin, from Benjamin. All right, we call this what? This gum benzoin, okay, or this gum benzoin or Benjamin, we call it an aromatic resin. We call it what? An aromatic resin. Aromatic resin. We call it what? An aromatic resin. It is used in the production of perfumes. It's used in the production of incense. Okay, all those things that smell nice. Okay, so take note of that. The word benzene is gotten originally from what? Gum benzoin or Benjamin. All right, and this gum benzoin is what? It's an aromatic what? Resin. It's an aromatic resin. All right, benzene itself was first discovered in the year 1825 by an English scientist. Benzene was first discovered in the year 1825 by an English scientist called Michael Faraday. Okay, he first discovered benzene in the year 1825. Okay, so it is not August Kekule. All right, so he discovered it, but the first person that named it, okay, benzene, was actually a German scientist called Mischarich. Okay, called what? Mischarich. Okay, he was a German scientist. Okay, in the year 1833, he was one that named what? It benzene. Okay, Michael Faraday first discovered it in the year 1825. Mischarich now what? Named it benzene in the year what? 1833. But after the existence of benzene, nobody could talk about. In fact, the structure of benzene became a mystery for a very long time. All right, so nobody knew how they could draw the structure of benzene. Okay, the structure of a compound that has C6H6 as what? Molecular formula. Nobody can draw the structure or form it from what? From carbon, which is what? Tetravalent, that has 4 bonds surrounding it. You know, carbon can only have 4 bonds surrounding it, right? So how can we now draw? There was a problem. How can we now draw the structure of a compound that has what? A formula of C6H6 from what? From carbon that has what? 4 bonds, that is tetravalent, that just has only 4 bonds. Okay, because what you can see obviously here, these are 6 carbon atoms. This is not C4 something. All right, this was C6. So how can we now draw it? So it became what? A mystery for a very long time, until the year 1865, whereby a German scientist, a German professor, actually, August Kekule proposed a structure. was Kekule, proposed a structure through a revelation. He was sleeping in the night waiting no good, and then he dreamt of a snake biting its own tail. All right. So when he had that revelation, Eureka! I have found what a structure. I'll be able to think about how we can what do the structure of what of this what benzene. All right. So he proposed that benzene, okay, has what a six-member what carbon. All right. It's a six-member what it's a six-member what carbon atom having what alternating single and double bonds. All right. So he dropped that. He said that what in the year 1865, August Kekule proposed a structure for what for benzene when he had the revolution in the dream, where what a snake was biting his own tail, and then he said that what benzene comprises of what of a six-member carbon containing what alternating carbon to what carbon what single and double bonds. Okay, alternating double and single bonds. So yeah, single bond, yeah, double bond, yeah, single bond, yeah, double bond. So this was the structure, something like this. This is benzene according to him, according to August Kekule. All right. So if the bond is here, all right, yes, double bond, here will be single, here will be double bond, here will be single, here will be double bond. All right. All right. So this was what it, and he said that each carbon has what has one hydrogen each. Okay, that's why the molecular formula here says what is 6 is what H6, C6H6. All right. So also the interactions of this double bond was not discussed by August Kekule. Okay, he only proposed it. Okay, the interactions of this double bond was not discussed by what by August Kekule. All right, another scientist, okay, called Linus Pauling, an American scientist called Linus Pauling, okay, was one that talk about what about benzene having an hybrid what structure, okay, with delocalized pi electrons, having what a hybrid structure with delocalized pi electrons. We're going to talk about that soon. All right, but there were problems, of course, in the proposition made by August Kekule, because naturally, there are single bonds here. All right, it means that what if these are single bonds, or it means that, of course, naturally, benzene should behave like what alkenes, because they have a single bond. But benzene does not behave like that. Benzene does not bond. It does not behave like that. Benzene do not what even undergo addition reactions, unlike alkenes and alkynes. Unlike alkenes and alkynes that undergo, unlike alkenes and alkynes that undergo addition reaction, okay, benzene does not undergo addition. It undergoes substitution reaction. All right. So unlike what alkenes and alkynes that undergo addition reaction, all right, benzene undergoes substitution reaction. If it want to attempt to undergo addition reaction, it does so with a great deal of difficulty. All right. So that was another problem. How come this benzene that's supposed to behave like an alkene, having what alternating double and single bond, it's supposed to behave like an alkene, but it does not what behave like what like an alkene. All right. In fact, it does not have any effect on bromine water. Okay, you know that our alkenes will decolorize bromine water. Okay, it does not even decolorize bromine water. That is even another point to note. All right. So why? Also, the length of carbon to carbon single bond. Okay, the length of carbon to carbon single bond is what? Is 0.154 nanometer. Okay, while the length of carbon to carbon double bond is 0.134 nanometer. All right, but the length of carbon to carbon bonds in benzene is 0.139 nanometer. Okay, so as you can see, obviously, it means that what that benzene, okay, has its own what special what bond. So it does not have bonds like the alkenes have, okay, or like the alkenes have. It has its own special bond. So the length of carbon to carbon bonds in benzene is what is 0.39 nanometer. Please take note of that. All right. So you see the problem. So now they now have to find what a resolution. In recent times, the resonance resonance has been used. The resonance concept has been used to explain what the structure of benzene. The resonance concept has been used to explain Resonance concept. Resonance concept has been used to what? To explain what the structure of benzene. What does this resonance concept say? It proposes that what benzene has what? Two forms. Okay, it has two forms, and then it has what? An intermediate what form. Okay, so let me show you what it means. It means that here we have what? Benzene, okay, in this form, having this single bond here, a double bond here, single bond here, double bond, single bond, double bond, double bond, single bond, double bond. All right. Then also it's like this. Okay. All right. Remember, we started double bond from here. Okay. Started from here now. So instead now we start double bond from what? From here. So double bond here. Okay, there will be single bond here, there will be double bond here, there will be single bond here, there will be double bond here. Okay, this is benzene, this is benzene. All right, so how you draw the bonds, okay, where you put the position, the location of the double bond does not matter, but what matters is that what there must be alternating double and what and single bond, or alternating single and double bond. So single double, single double, single double, double single double, single double, like that. Alternating single and what and double bonds. All right. So they will now have what the resonance. These are the resonance forms. These two are the resonance forms. Resonance forms. Okay. They will now have the resonance hybrid. All right. In that hybrid, we just have this. All right, so we don't have this, okay, and what this. So we can use this to just represent what benzene. Okay, so this is what resonance what hybrid. Okay, so please take note of what of that. So this is the resonance form. So instead of writing this or this, just what draw what that shape there. That is what your benzene. Okay, so resonance concept in recent times what we have used to what to explain the structure of what of benzene. So a few things we have learned so far is that what that the benzene does not what behave like the what like the alkenes or what like the alkynes that undergo addition reaction. Instead they undergo substitution, and even if they want to undergo their addition, they undergo addition with a great deal of what of difficulty. All right, and then we said also that what that the double bonds, okay, that the bonds in what in the benzene, okay, in the benzene ring, all right, they are not what bonds like what like the alkenes or what like the alkynes, okay, or like the alkenes or rather and the alkenes, okay. Instead they have their own special bond, being that what the length of carbon to carbon single bond normally is 0.154 nanometer. The length of carbon to carbon double bond is 0.134 nanometer, but the length of carbon to carbon bonds in benzene is 0.139 nanometer. All right, then of course we have said like Faraday discovered benzene. It was named benzene by German scientist Mischarich, and then of course the structure of benzene was first proposed by August Kekule in the year 1865. Linus Pauling, an American scientist, was one that talked about the interactions of the double bonds, okay, in the benzene ring drawn by Kekule. All right, so please take note of all these pointers. They are very, very important. If they were not important, I would have told you so. All right, so now, right about now, we're going to go to the OTD School JAMB app. But for that, if you have not liked this video, what we're doing is wickedness. Now, wickedness you do. So please click on that like button. Do not be wicked. Just click on that like button immediately. Do not forget to also share this video to your friends and loved ones. Subscribe to this channel, because once you do so, once we release a new episode, you'll be the first to know. All right, so let's go to the app and answer those questions, and we are off. So the 2022 question number 19 we started with is being shown on the screen right now. Dash is a hydrocarbon with a number of double bonds that interact with each other. Of course, that is what now arenes. Okay, A say arene, B haloalkane, C ethane, D ethene. Those are what benzene and its compounds, which are what arenes. All right, so it's shown here. Now let's see another question. They say this is a 2003 question number 45. They say the type of reaction 2003 number 45 is being shown on your screen right now. The type of reaction that is peculiar to benzene is A, addition reaction, B, hydrolysis, C, polymerization, D, substitution. So we say that what benzene undergoes mainly substitution reaction. Even if say they want to undergo addition reaction, they undergo addition reaction with a great deal of what difficulty. Now, this is a 1998 question number 50. Okay, let us leave that for now. Then this is which of the following exhibit resonance? This is a 2021 question number 13. 2021 question number 13. They say, which of the following exhibits resonance? Exhibits resonance. Okay, of course, definitely is what is benzene. A say benzene, B say butane, C pentene, D octane. So correct answer there is what is benzene. All right, so please, there are many more questions about this topic on this application. So go to Play Store, download the O3 Schools app immediately. Start practicing your way to genuine success in your exam. 300 is very, very achievable. If you want it, you can get it. My name is Master T, the Grand Commander of this great O3 Schools army. All right, I would love to see you at the top. Hope to see you there eventually. So in the next class, we'll talk about benzene and its derivatives. Thank you for watching.